We are going to talk about dictionaries in Python today. And dictionary is one of the pillar data structure that comes built in Python language. Python was one of the first languages to provide this as a built-in. They're very powerful data structure and will help you solve a lot of different type of problems and also speed up the process as well. So let's quickly jump into what dictionaries are first. Dictionaries, for short, I'm just going to write dict. This is the class name, dict. And while we do this, let me also fire up the terminal and try this here. Few important features about dictionaries. So dictionaries are hash maps. For example, in Java, you call them hash maps. You can refer to as just map, or some people call it associative arrays, or finally, you can just think of it as this is a store for key values. So you can store a pair, essentially. One of the pair is called key, and the another pair is called, sorry, another part of the pair is called value. The first item is called key, the second item is called value. So dictionary is this some structure where you tell Python to store a key and a value, and it goes in and something happens and it gets stored somewhere. Later on, when you can ask dictionary, okay, what is the value of this particular key? The dictionary will return back a value v for that. And this operation, it's kind of, if you notice, it's kind of similar to array, in which array has indexes. So you have indexes and you can store something on those indexes. For example, you can put 3.14 here. So you know at the fourth index, that is index 4, which is kind of a key, the value stored is 3.14. So when, let's say this array was a and you write a of 4, this returns you the value back. The only thing that changes in dictionary is that the keys here are just numbers. The key here can be anything. So you can literally store any type of pair. And the first thing will become the first value. The key can be anything. So the first item of that pair will become the key. Although there is one limitation that I'll talk about later on. So dictionaries are key value storage. And some things have changed about dictionaries. Dictionaries used to be unordered collection. So the unordered collection means that if, let's say, you stored in dictionary first key one and then value one, then later on key two and value two, like that, then it would not necessarily store them in this order. It would not remember the order. So if you would iterate over the dictionary, whatever the dictionary's implementation was, whatever the key was stored first would come out. So if you may have stored it in this order, later on when you would go and retrieve one by one, maybe K6 will come back first. This used to be the case. But ever since Python 3.6 version, the dictionaries have become ordered. And they're called insertion order. So dictionary remembers the order in which you are inserting inside a dictionary, keeps track of that. So now if you retrieve the value back, like we generally write like an iterator, like for keys in this dictionary, give me the keys back. It will come back in the same order as you inserted. So now, essentially for all practical purposes, the dictionaries are ordered. Before that, they were unordered. If before 3.6 version you wanted to use an ordered dictionary, then there was a separate dictionary which was different from this dictionary. It used to be called ordered dictionary. It used to be called ordered dict. That would do this purpose, do the same thing for you. But now this is no longer needed from 3.6 above. So they are ordered. Any item that is inside a dictionary is accessed by its key. So suppose if this is the name, this is the dictionary, then the item that you will get from the dictionary will be d of k, just like you will do for an array. You can write array of 0. So whatever the key is, you put it in these square brackets, and dictionary will get you the value back. Essentially, dictionary supports, I mean, for all of the languages, dictionary is meant to support three operations. One is called a put, one is called a get, and one is called a delete. This is the terminology used in computer science world. Right? In Python, these are not necessarily the name of the functions. They can be different, and we'll see what those function names are. But essentially, you can insert a key value pair. You can do a get on a key, or you can delete some key. These are the three operations that the dictionary supports. Now there are more in the dictionary library that we will see how they work, but these are the fundamental operations that dictionary has to support. A hash map has to support. The this is not concerned. This does not concerns this particular class, but one of the computer science implementation detail is that what makes dictionary really good is the fact that all of these operations are done in a constant amount of time. If you don't understand this, that's fine. But basically, regardless of the size of the dictionary, you can search an item inside the dictionary in constant number of operations. But yeah, this is okay. We don't need to worry about this. And finally, dictionaries are mutable. So if there inside the dictionary there is some mapping, let's say k1 is pointing to some kind of a value v1, k2 is pointing to some kind of a value v2, k3 is pointing to v3, and so on, then you can tell in the dictionary to, instead of k1 pointing to v1, you can tell it to point to something like something vz. You can change this object, this particular object, in place. That is allowed. They are mutable. And there is indefinite amount of nesting that you can do inside the dictionary. So I mean, for example, not the key, but the value can be another dictionary, and that value can be another dictionary, where you can have a key value where value is another dictionary. And I think this will become more clear when we solve some examples. This is more of an example thing. So any questions? Let's get started with the examples and things will become extremely clear. So first thing, the dictionaries are represented by curly brackets. So this is a dictionary. This is the class dictionary. And then there are many ways in which dictionaries can be initialized. Let's initialize an empty dictionary. So now this is a dictionary. You can call len on it and you will get an answer that the length of this dictionary is 0. Or you can initialize a dictionary in this way. You can say, this is an empty dictionary. Now you can put your key value pairs right here. You can say that my first key is, let's say, 1000. And the corresponding value for 1000 is, let's say, a string called something. It's a random dictionary that I'm creating. So notice this. This is a key. Then you put a colon, then a value, then comma. So this is one pair that you have put in. Then you can put the next thing, basically let's say 2000, and you can put, so now this dictionary has two keys. If you do a len on this, you will get that the length is 2. There are two dictionaries here. Now, if you want to access a value inside inside this dictionary, then you write d of 1000 or d of 2000. If you write something that is not existent in this dictionary, then you get an error back, which is called a key error. This is a very common error that you will see many times when you code in Python. When a key is not present, then you get an error that it's essentially key error, that this key is not there. And you have, whenever you referencing some key, I'll show you shortly, whenever you write code, you will always make sure that a key is present in the dictionary before you do anything with that key. So you'll have to check something like 3000 in D. That will come out as an answer. Notice the similarity of the built-in functions. The in works, the in keyword is working, the len is working, and even this is very array-like. At this point, the D could have been anything. As long as this is a valid index or key, this will continue to work. Any questions so far?
Yeah, just a quick question. So how do you reference the first key value relationship? Like, let's say you just want to reference 1000 to something. You just want to bring only that portion out.
So let's say you write this, like you get the answer. Is that what you mean?
No, but what I want you to bring out is that you're bringing out both instead of just referencing 1000. You know how we reference maybe the first elements, say in a list, for example.
So keep that in mind. Dictionary, I will show you a way. Okay, when we do the looping, the first item will come out. But keep that in mind that dictionaries are not like your sequences. Okay, they are preserving your insertion order, but they are not fundamentally a sequence, right? So there is no first or last. In dictionary, you're just putting stuff and you're retrieving it later on.
Mm.
Although, let me see if there is an iterator that can. Okay, so there is an iterator. You can just say it equals to that. When you do next of it, let's see what comes out. So that's 1000. That's the first key, then the second key, and then stop iteration. So this is what internally for loop also uses to iterate over a dictionary. So essentially, uh, this is your, per your question, this is the first item. This was the first item. Although once again, dictionaries are not sequence. Just to keep that in mind.
Uh, Himanshu, one more question. Do you have
Yes.
like a key value pair directly, like while you're iterating,
Mhm.
item can contain like a key and value?
Yes, you can do that. I'll show you. Don't worry.
Okay. Yeah, and another question is um, I see how you insert a value into dictionary. Can we directly suppose a D of 3000 directly? Can we assign a value like that? Because
Yes, you can. Yes, you can.
supports. Okay.
Yeah, you can. All of this is coming up. Don't worry. When we come to, I mean, right now I'm just showing you how to create a dictionary. I'll show you how to add things to dictionary, remove things from dictionary. So all of this will start coming up.
Are there any limitation on the type uh, of key? Like, can a key be iterable?
So this is a good question. I did mention earlier that there is a limitation on the type on key. The key can be iterable. Although this important thing is that the key has to be immutable. The key of an object cannot change. And the reason is it's slightly deeper. Uh, I'll cover it briefly. these keys, how does Python know how to find something? Okay, so whatever is the key is, it gets passed through a hashing function. And the hashing function generates some kind of a number for this. Okay, X, Y, Z, 1, 2, something, something. That becomes the identifier for the value. This tells Python where the value is. Usually this is the memory address as well for the objects. So there is the value. Anything that is mutable, its hash can change later on. So Python will not know where that object is stored. So long story short, the key has to be immutable. So if I create a key, suppose this is the dictionary, and let me create another dictionary. Suppose I create the first key as a string, let's say name, and let's say the name is my name. So this is okay. But if I create a dictionary, which is second thing is, let's say, a list, which is 1, 2, and the value is, let's say, value, then this is an error. And the error is that list is unhashable type. So a list cannot be a key. So what can be a key? A number, string, tuple, or anything that's immutable further.
Thanks.
Does it make sense? This is an inbuilt function called hash. Hash can tell you things. For example, if you do hash of, let's say we create a variable called x equals to, although we're getting into details, I'll just briefly come over here. So if you do hash of x, it generates some kind of an identifier. So this identifier is what is used to really find out how to reference that object. Internally, this gets mapped to a memory space, and Python just directly know how to get to there. So that's how it works. But if you do a hash on, let's say, maybe a list, you're going to get an error. So you're going to say that list is not hashable. Why? Because list is mutable. It may change later on, and the hash function will change. So you can't really do hash on that. Okay.
Makes sense.
Yeah.
So, could I ask? I have a question. So, basically, when you're making a dictionary, what's to the left of the colon is the key, and to the right of the colon is the value.
Yes. When you create
And-
dictionary, this is key, and this is a value.
And those key value pairs make up a dictionary.
Yes. One item of the dictionary, for example, this is the dictionary. This dictionary has only one item in it. This is this item, key value pair. If you do a len of d, that will be one item.
So you have to always have a pair when you're making a dictionary.
That's right. That's right. You can't just say something like this. For example, if I go here,
Like earlier, you can't just do 1,000, 2,000, 3,000.
you can do that, but something else will happen. If you do this, then what you have is not a dictionary. You have, this is actually what is the type of function? Let me
I think
give me-
type.
what is
Yeah.
that? Oh, this is
Type.
just type. Okay,
I think.
type of D. Yes.
Typo
So
is
in that
JavaScript.
case, if you notice that it's not a dictionary, it's a set at that point. So you're doing this, you're thinking that you're creating a dictionary. It's not, it's a set at that point. Whereas if you inserted the dictionary in this way, sorry, let's just get rid of this. And you the type of D again, then this will be a class dict. Do you notice the difference?
Yes, I do.
Yeah. So keep that in mind.
Right. That makes sense now. Thank you.
Yeah. So we created a dictionary just by itself like this. Okay. Let's create another dictionary. Suppose this dictionary is the dictionary of, let's say, countries and capitals. So suppose you have USA, the capital is Washington, and let's just add a couple more. Maybe let's say you have Australia, and then capital is Canberra, and maybe finally you have Japan, and let's say the capital is Tokyo. So you have both the key and values as strings in this particular case. So when you do dictionary, you get this. You get you len of D, you get the answer. Now that's why this dictionary has 3 keys in it. Now let's first of all let's work about one by one to some basic operations, adding items to this dictionary. So if you want to add an item to a dictionary, all you have to do is you have to specify a new key. Suppose you want to write France, and you will just assign the value to it. You're going to say D of France equals to, let's say, Paris. So this will automatically add a key value pair, France and Paris, to the dictionary. A very simple way of adding stuff. There are more ways. I'm going to cover everything later on. Similarly, if you want to, let's say, find whether something is present or not, you can just look for that like this. You can say, what is D of France? You get Paris back. Or if you want to edit something, let's say in the same notation, let's say you want to write, for whatever reason, let's say you're writing D of USA equals to, let's say, Los Angeles. So this is okay. Python is gonna just remove the existing value for this key and put Los Angeles as the value there. And once again, I'm just gonna put this back. And so you can edit a key by just assigning the value. You can add a key by this type of declaration, like assigning a value to a key, and the key and dictionary value both will be added. When you're referencing it, and the type of reference, you have to make sure that the key is present in the dictionary. Okay, when we solve some bigger problems later on, I will live demo the problems that come up because of that. But if you do, let's say, something else, let's say you do India like that, so it will get an error, that this key error, that this country is not present in the current dictionary. Okay, now there are multiple ways to create dictionaries. Okay, I'm just going to show you some, and then I'll add these on my GitHub page as well for quick references later on.
Can I just quick ask before?
Yes.
I know earlier you mentioned that dictionary doesn't work with sequence, but just to ask, are you able to specify where you want to add a particular, key and value?
When you say where, meaning like a location inside the dictionary, you are saying?
Yes.
So there is no such thing. Once again, I think
no problem. No problem. Don't worry. Let's move on.
Yeah. So essentially, let me just quickly go over. Don't worry. In list, there are predefined slots. You have these slots, and this slot is called 0, 1, 2, 3. So you can specifically say, okay, I want an item, let's say, to go in the 4, and you will say, let's say, 100. So then this 4 starts pointing to 100, or simply, let's say, 100 is here. You can do that. In a dictionary, you cannot do that. When you say dictionary of, let's say, 5, then this 5 is hashed. That returns a value. Okay, and hashing function can return any value. Somehow this value is mapped to a memory location somewhere, and there is your object. The value for that is stored. So next, let's say you do D of 6, it might be a completely separate location somewhere else. So you have no way of saying in the sense that this is not ordered here. There is no ordering. There are many ways to create dictionaries. Okay, so I'm just quickly going to go on some of the ways so that, and I'm going to put these in on my GitHub page, so it will be quick to reference as well. So you have
Question.
a constructor, yes.
I thought Python since 3.7 is now ordered. The insertion order.
So the
is-
insertion order is preserved. So
Okay.
all it is doing is it's remembering in what order you inserted the keys. But you cannot tell Python which location you want this.
Sure.
You cannot say that insert a key between, let's say, key 1 and key 6. That is an array attribute, right?
Yep. Yeah.
So Python is going to remember the order in which you're inserting the keys, but that's all.
Yeah, and the memory that you showed before, it's actually stored like some hash table, but it's like sparse, right? There's
Exactly.
like empty slots.
Yeah.
Okay.
All right. Yeah. So some of the methods. So there is a constructor dict that can work on certain things to form the dictionaries directly whenever you want. So suppose what you can do is there is a method called from keys that can take an iterable and create a dictionary from it. Suppose this iterable is, let's say, Saturn, a string. This returns a dictionary where each item of that iterable is a key and the value is none. So this creates the dictionary for you with these many keys. Now you can adjust it however you want. And there is a better way of doing this as well, where you can combine the two iterables to generate the key and value pairs. That is a different method. So suppose you have, let's just say list, let's just take list 1 equals to 1000, 2000, 3000. And let's say list 2 equals to some random string x, y, z, and then in the previous class I gave you an assignment to look up at the zip function. I don't know if you got a chance, but zip function can combine these two lists into some kind of a tuple form like this. So you can do this and you can just, let's just cast it into a list. So zip can take two iterables and combine them in the form of tuples. So 1000 higher combined, 2000 xyz are combined, and this is combined. So you can also put a dictionary on this constructor, and that will result in a key value pair like this. So you have, let's say you have two collections, you can combine them in this way. Suppose there is a list of some tuples and the tuple values are, let's say 1, 2, 3, 4, and let's say 5, 6. Let's say you do just call the dictionary on this and automatically these are converted into key value pair. So dictionary, this constructor has some understanding of how to go about this, creating these values. And finally, you can just give it key value pairs. You can say, earlier we created this kind of a format. We said name equals to, let's say Himanshu. Sorry, my mistake. We created this kind of format where we say dictionary equals to this guy and like this. This is fine. You can also just create any arbit key value pairs in this way. You can say name, there's a variable, you're saying name equals to some kind of a value, let's say Himanshu. And you're saying address equals to, let's say something 123 coding way or something like that. When you call this kind of a, you have, let's say, two variables You just put them by comma separated values and you cast dictionary on it. It will automatically convert that into key value pair for you. So in your program, let's say if multiple variables, you want to put all of them in dictionary in one shot, you can just do this. And once again, I'm going to put all of this in the reference so you can practice it. At this point, I'm going to give you a minute, okay? Maybe a couple of minutes. You can try this out and see. And if you have any questions, you can ask me. All right, so now we begin some operations on dict. So I'm just going to first of all explore the dictionary class and look at the functions here. Once again, I'm not going to focus on double underscores. So clear, copy, from keys, we use the from keys. There's a get. Clearly this looks like that it can get some value. There's items, keys, pop usually is for deleting, pop item. Let's see what the difference between the two is. Set default, update, and values. Let's look at what these things are. Suppose you have this dictionary and let's just go a little back. Let's see if we can find a bigger dictionary. Yeah, this is good. So the first thing is you can look at something, for example, using the key, or you can also look at d.get to get the value. Now, why the two things are doing the same thing is because this will give an error every single time if a key is not present. For example, we saw about the key, for example, India, you get an error. But in the d of get, if you specify, let's say, a code, you can also specify that if this is not present, then what is supposed to be returned. So you can say, let's say, return -1 if this is not present. So this does not throw an error. You can instead, your program will not terminate. You can get a value and then you can act on based on that value. And this is very helpful. We will see that in example. Whenever, let's say, you want to say something like, if the key is present, then increment the value. The key is not present, then create that value. In that situations, it becomes very, very helpful. We'll see that. So this is the get method inside that dictionary. Let's look at some more methods real quick. There is something called d.keys. This tells you all the keys in one shot. Now notice that this is not a list. Okay, this is something called a view object, which we don't need to worry about here at the moment. Similarly, there is something called d.values. So this gives you all the values that are present inside the dictionary. And finally, there is something called d.items. That tells you all the things that are present, all the key value pairs in the tuple forms. You can force it to become a list. You can say, okay, whatever this object is, just cast it into a list, and that will give you a list back. So if you want to get an idea of what are all the keys, what are all the values, what are all the items present in the dictionary, you can just do this and you get the value back. I'll give you 1 minute if you want to try this out. Okay, how do we remove items from dictionary? So removing the item from the dictionary, the pop method works. Now, if you write d.pop, that's going to be an error because here pop does not know what is to be removed. There is a separate method that can help you, but pop historically never knew that what is the last item because there is as such no last item. So in this case, you have to supply a key. You can say remove, let's say, Australia, and that will remove the key Australia and its value, and the dictionary is changed in place. Let's say if you try to remove something that is not present, let's say Australia again, then you get a key error that this key is not present. So basically you can remove the items from dictionary using a pop method. Some more small things. Suppose you have a dictionary And let's say you want to add, let's just create another dictionary. D1 equals to, this one is, let's say, Australia, and the value is, so let's say you want to add these two dictionaries. If you write D plus D1, that is an error. Okay, Python does not support the addition between two dictionaries. If you want to add one dictionary to the other one, you will have to use a method called update. So when you say update the dictionary D with the values in D1, when you write that, then you will notice that this Australia has been added now as a key here in the original dictionary. You don't have to remember anything here. Okay, just when you practice, I'm just showing you the functionality, what is all available, so that you have this in your mind. Later on when you code, you will know that there is something that exists and you can look up. With that, I'm going to switch to the IDE because we're going to do some more, a little bit more advanced stuff. Let's save this. So the very first thing I want to show you is the looping in a dictionary. The simplest syntax for looping in a dictionary. Suppose this is your dictionary. So the simplest way is, right, you can say for key in dictionary. This will never change. This syntax is the most simplest one and always works. For key in dictionary, print the key. Suppose this is your syntax. When you write it, this will print all the keys that are present in the dictionary. Let's say you want to print keys and the values. So essentially you can write something like key, comma, you can put, let's say let's just put this and the value of that key inside the dictionary. Here you don't have a problem that this key may not exist in the dictionary. That's not a problem because we're just looping with, and those keys are coming from the dictionary itself. So when you run that, you will get something like USA and Washington, Japan and Tokyo. So simply you can just loop through this dictionary with just one small syntax for key in D and then do something. All right, take 30 seconds if you want to try this out. All right, let's take up a problem. And this problem is called character count. Okay, and this, I'm using this as an example to explain certain things. Suppose you have a string. Okay, the string is something like, my name is, let's say, Frodo Baggins. And you are asked to count the occurrence of each character in the string. All right, and count the occurrence of each character and then later on whatever show it. So then how can you do this? Right, so this kind of a problem naturally falls in the realm of dictionaries. Let's just quickly go over here and see this example. So this is a string, and a string naturally has some indexes 0, 1, 2, 3, 4, and like that. So you want, if humanly you were to do this, you will check there is an M, and then you will check, okay, there's an M again here, so there are two. Then you will come here and check if there is no M, then you're good. So you'll put somewhere that M, there are two M's. Then similarly, you will do the same thing for Y, and you will keep track of this. So that's how you humanly do it. And that's how you will do it in the case of dictionary as well. This is the key value store for your dictionary. The key is the character, and the value is the count of that character. So when you want to do this, what you can do is you can create an empty dictionary first. Then you can go through this string from left to right. Check the character present here. Take that character out. So first of all, M comes out. Then check whether this M is in the dictionary or not. If that M is already present in the dictionary, then it might have already some kind of a value. So we just increment that value by 1. Right now, the M is not present in the dictionary, so we just directly store it inside the dictionary. We put M and the value as 1. Then we come to second character, Y, and we do the same thing. We check if it's present in the dictionary. If it's not present, then we just create a key with Y and put this as 1. Later on, you create more keys. Okay, and suppose you created a key with O. So the O was 1. Then when you reach this place, you will check whether O is present in this dictionary or not. The answer is yes, it's present. So then you have to write a logic that whatever is the value of O, increase it by 1. So it becomes 2. So this kind of becomes a natural candidate for storing this type of information. Here you want to collect information based on the characters and not the indexes. Although this can be done with array as well. So let's write a simple piece of code for this. Suppose I'm going to create a dictionary called chars. Okay, this is an empty dictionary for me right now. And I'm going to say for each character in this string, for each of the character in this string, let's just say we write some sloppy logic and we say chars of x I can't think of the sloppy logic at the moment. Okay, let's say we write chars of x plus equals to 1, something like this. We're saying that for each character, whatever is the value of that character, plus equals 1. And then we think, okay, let's just print the characters. So when you run this, you get a key error. Key error is n, that the key is not present. So the error is coming because you're writing chars of x plus equals 1. So essentially this translates to chars of x plus 1. Now when you do that, the m is not present in the dictionary yet. Since the m is not present, you're trying to reference a key which is not present in the dictionary, and hence you get an error. So that was the error. Now the good way of doing this is to first check if x in chars, that is if x is present in chars, or you can write if x is not in chars. Okay. If x is not in chars, then you have to create a new key with that value. Right? Just give me 1 second. If this character is not present in, if this whatever the n or that particular letter is not present in this chars, then you have to create that key. And how can you create that key? You can say chars of x. Create that with a value of 1. So here you're creating a key. Else, that if this is already present, this character is already present, then you write chars of x plus equals to 1. So when you write, suppose you have a dictionary and you write USA in D, that's true. And when you write USA not in D, that's false. So if you check, let's say if India not in D, that is a true statement. So that's how you write this. If this letter is not in the chars, which is true, then create this with the value 1. Else do this. And this is the template logic that you'll always use. Now just print the chars. So you will get this kind of a dictionary in the end. Let's print it a little better. Okay, so suppose we're going to say we're going to use the logic from here. Say, for key in D, for key in chars, okay, print dot format key k comma chars of k. So now we run this code and you will get the answer in this way. Now, few things to notice. The capital M is of course different from small m. The two are not the same keys. Python is case sensitive. So if you want these to be same keys, then you have to either force lowercase everything or force uppercase everything. But that's a normal outcome of this language. So this is space. There are 4 spaces that is also counted as a character. And you can basically print the whole value like this. Any questions in this logic?
You could replace the if else with a ternary.
Can I replace the if else with a ternary?
Yeah. So if x not in cars, just cars x equal 1. I mean, I don't remember the syntax for ternary in Python.
I'll
Else.
show you a better statement in a second. Just give me 1 second.
Or something with an and shortcut.
If you remember, I showed you a get method. Right? If you do a d of get of, let's say, USA, get this. And I'll show you right now how we do that. So the similar logic, once again, can be written in this way. I'm once again going to parse this dictionary again, and let's just call this one as chars of 2, which is an empty dictionary right now. Empty dictionary. Now, let's just write this again. I'm going to say for x in S, I can write this logic to populate chars 2 as well, or I can use something else. I can write chars dot get of, let's say, x. Now this will return a key error if the x is not present, or it can return some default value if we pass it. So we can say that if this key is not present, then return a 0. Then we can write chars of whatever this x is. This key should have a value of whatever the value of this is currently, and if it's not present, then 0 plus 1. So that becomes a one-liner statement. You write print chars 2. Let's just be clear that we are correct on syntax. So for example, when the M comes now as the first character, let's say my name is Frodo. So capital M comes here, and you say this should become chars 2 of M. Essentially, you're writing this, that chars 2 of M should be get the value of current key, that is the value, the key with key which is M. So this will give you now a 0 if it's not present, which is ideally what you want. And then you just plus 1. So this will insert M and 1 in it. Otherwise, let's say this was value 2, then you will get 2 back, and then you can add 1 to it, so it becomes 3. But essentially, you can do this in one line with this. Whatever you feel comfortable with, you should do that. I several times use this, and sometimes I use this.
Yeah, I like that. I like the cleaner syntax. Well, at least to me.
Yeah.
The second one.
Any questions?
So when you say parsing, is it similar to iteration?
Parsing of string, you mean? Parsing meaning scanning something, right? So in this case, we are scanning this string from left to right. Is that what you're talking about? I'm not sure if this is what you're referring to.
Yeah, kind of a beginner question. So whenever we do a parsing, and sometimes we say we are doing iteration in a loop,
Yeah, it's the same
it's,
thing.
it's the same thing, right?
Yeah, it's the
Okay.
same thing. Yeah. In this case, yeah, it's the same thing. Any other questions?
So you mentioned to delete pop method. Pop returns the actual value that you're removing.
Right.
And then you also have a remove method, but that is doing like another search or loop or whatever,
Let
right?
me
If you're using the remove method.
Is
and then
there a
you
remove
have,
method? Let me check.
then there's also delete.
Hang on.
So you have
Where
three options.
is the remove method? There is no remove method, right?
No, rem, delete, del. But I
Yeah,
think
so
that's separate,
the del
built-in.
is the built-in. It can
Built-in,
take,
yeah.
yeah, it can delete pretty much anything that you want. So if you say del of USA, just delete that. This will just
Right.
delete it. That key is now gone. Or you can just write del of
And
D.
then there's
The whole dictionary is
exactly.
gone now. Yeah, so that's a built-in that you can always use. But
And
yeah,
then remove. I thought there was a remove method.
remove was in the list, if you remember.
Oh, it's a list.
Yeah.
Okay.
In the list, there were two methods to delete. There was a pop and then there was a remove. Pop works on the indexes and remove works on the value
Oh
of
yeah.
that particular
Right.
array.
Oh, okay. So I meant for the list then. So
Yeah.
then I guess if you use the remove for a list, that's extra complex, or it's
It is-
extra
yes.
calculations because it's got to search, do another search within that list.
That's exactly correct.
Right. Okay. So it's better to use pop or delete the built-in.
I mean, it depends. If you have to find an item and you have to delete it, then there is no other option but to search it. So you remove has to be done.
Well, yeah. I mean, if you're already in a for loop, for instance, right?
Yeah.
You're looping through or iterating through, then there's no point of using a remove again because you're looping again, relooping, or doing an inner loop.
Right. So what is remaining now? There are a few things that I want to talk about, which I'm going to carry on in the next lecture. First is the nesting in the dictionary. We have not talked about that. A dictionary can contain a dictionary, which can contain another dictionary, and it becomes a very interesting and very meaningful data structure in certain senses. Suppose I have an ID, and that ID is the key, and the value is the new dictionary, which can be something like, let's say, a name with some name. Right, so this itself is a dictionary, and then you have, this is nesting of the values inside the dictionary. You have another dictionary, which is, let's say, and then you have address, which can be another dictionary, which can have a key called street. And you can put something like 1, 2, 3, whatever, coding way, and city as something else. This lets you access the data structure in this way that you can say, okay, student with the ID, what is the city, or what is the address, or what is the city inside the address. So you can go any level of nesting inside a dictionary. Okay, we're going to talk about this in the next session, nesting. Then we're going to talk about sets, very close cousin to dictionary. And we'll see what the difference is, some set operations. And then finally, files, that how to read and write files in Python. The assignment for today. I hope you guys are, pretty much everybody I hope is doing the assignments, because if you're not doing it, it will become very, very hard now for you to carry on with this. You can listen to the theory, but if you don't solve it, then these concepts are never going to solidify. Now, I hope you got a chance to look at this join, split, map, filter. If not, do this. You will need that in the assignments that are coming up now. Okay, and for this one, there is a dictionary library, so this directory. I already have two here assignments, where is count letters and count letters sorted. I want you to take a shot at these two. After the next class is done, we will be looking at another assignment which is kind of interesting, in which you have a novel. There's a book called Little Prince. If you haven't read it. It's a pretty good book. And we have to count all the occurrences of all the words in this whole novel. It's a big, fairly decent sized novel. So we're going to do that. But for this one, you have to count letters and count letters in the reverse sorted order. So you can check the description here, try it out, and send me your code or whatever the output you want to send.